So good morning, everyone. Welcome to another ASQ webinar series. It's a pleasure to, on an easy Sunday morning, we'll also have this particular session. And today we have an eminent speaker. And before I introduce our speaker for today, I'd like to just to give you a quick update on ASQ and then bring our speaker in. So without any further ado, let me just quickly jump into that couple of slides we have. Welcome. ASQ is over 70 years old organization born in Milwaukee and spread about 140 countries. We are basically a member-led organization, and our certifications are considered as world standard. And we have our regional offices in China, Mexico, and India. And we welcome all the people from the quality fraternity and people who are not associated yet with ASQ. Welcome them to also join today, and probably you might find an opportunity to join us as we move forward. Can we go to the next slide? Yes. In India, ASQ has been present for over 20 years, indirectly through our members. Last 10 years, we have been present directly. We have our local community members and chapters across India. And the network access about 60,000 members in India and other places itself. We have exam centers across the world, 8,000 locations we use for metrics. In India, we deal with about 350 odd clients. We have footprints about 12 odd industry verticals. We have experts who are Six Sigmas, Master Black Belts, reliability engineering, quality management, auditors, and various other programs that we run. There is ASQ certification exam trainings, all the global standards and all the programs that the ASQ provides are all available in Indian and in Indian currency itself. We work with many of the leading corporate houses like the Tatas, Mahindra, the Birlas, BAL, DRDO, to name a few. We'll go to the next slide, Greg. We also recognize that India is a country where a lot of brilliant quality work has been done. There is a lot of team efforts, and in order to recognize their efforts, last 4 years we have been hosting the ASQ Team Excellence Award, which is in line of the International Team Excellence Award, which has been happening for over 30 years in the US. And many of the leading companies that you see here have been winning this coveted title as well. So if you are doing anything brilliant, good in this pandemic time, I would request please look at participating in our South Asia Team Excellence Award. This time around, it will be in the month of November, and we look forward for your participation. It will be a virtual for the time being because of the pandemic, but it will be an exciting session to be part of, and it will be live. Greg, can I request for the next slide? Should you have missed any of our previous webinar, I request that please go on to our YouTube channel named ASQ South Asia. You'll have all our past webinar series, right from addressing improving quality of quality professions to supply chain, emotional balance in turbulent time, and of course today we are talking on an exciting topic on Quality 4.0. Next month we have NK Sharan, the Vice President, Tata Business Excellence Group. He's going to talk about their journey, Tata's journey, in how the Tata culture has actually enabled them to cover this, the pandemic time itself, and how business challenges are being dealt in the current environment. So please do note the date and time. It's going to begin on a Sunday, September 27th, 11 a.m. Look forward for your participation. And let me introduce our today's guest. Greg, next slide, and that will be yours. And I'll just quickly introduce you and hand it over to you, Greg. It's my pleasure to introduce today's guest speaker, Dr. Greg Watson, who manages a boutique consulting firm in Espoo, Finland. He is past president and honorary member of both American Society for Quality and International Academy for Quality. He has received the top honors from American Society for Quality, European Organization for Quality, and the Japanese Union of Scientists and Engineers. He is the first non-Japanese quality professional to be honored with the Edward Deming Medal for Distinguished Service in Promotion and Dissemination of Total Quality Management Overseas. He has been named an honorary member of 18 other quality-related national Association. Dr. Watson has written 12 books and over 6,000 conference presentations, journals,
600.
600. Oh, this is 600. Okay, yeah, 600. That's right. Thanks so much. And of course, he's been living in Finland since 1994. This brings into another point where Dr. Watson in 1998 wrote an article in Quality Progress magazine named Digital Nails and Electronic Hammers, and predicts this transformation of quality community and has been recognized thought leader in this movement since it erupted in 2017. Greg, without any further ado, I think everybody is wanting to know about Quality 4.0 and how they can prepare their organization and take it to the next level itself. So, Greg, over to you, and we are all looking forward for an exciting session from you. Thanks so much.
Thank you, Ananda. Well, welcome. We're going to be talking today about this topic, Quality 4.0, and it's divided into three sections. We'll talk first about the current trends that are influencing quality in the near term, and then we're going to talk about how to do smarter data inquiry. Quality 4.0 is basically about dealing with digital technologies and all of these advanced technologies we hear about all the time. And so the question is, how do we go into that? You just don't step up and go buy a big system turnkey and then say, okay, now we're doing it. And then finally, it can cost a lot of money. And so we're going to talk about maybe easing into it with some frugal engineering tips on some things that you can do with digital data. Because we have to sort of feel our way through it. And you'll see a little bit about what I mean as we get into this conversation. So first, the current and near-term trends. So there's some technology growth trends to consider. And when I wrote that article in 1998 about the digital nails and electronic hammers, I was being a little tongue-in-cheek, my choking a little bit. But it was basically about saying that in roughly 20 years, we would have agent technology, we would have automated data streams, and we'd be able to manage these and set our factories according to basically an automated system, and it would sort of be hands-off. And this isn't the first time that was forecast. I was remembering in the 1980s, there was a lot of talk about the idea of the smart factory. And that the smart factory was going to be a place just like this, that there would be no people. As a matter of fact, there was a standing joke back then that the factory would have two employees. There'd be a man and a dog. That the man would be there to feed the dog, and the dog would be there to make sure the man didn't touch anything because the machines ran it all. So we're going to get to this place because over the years, we've had these technology growths. So memory capacity. If we have more capacity, we get more data. And this is exactly what's happening. I remember when my computer had, hang on to your seats, 5 megabytes of memory. and now I'm almost at a terabyte on this system. Memory access. The faster we can get to the memory and use it, that means the data is available and we can do something with it. Microprocessor speed. The processing means that the calculations can be done faster, and now they can be done in parallel. It used to be that all processing was done in serial, so you had to wait for one processor to finish before it could start another. Data transmission, I don't know about you, but I'm in Finland and we have 5G. So everything gets better, we have more resolution, everything's clearer, you have the full functionality of all of the internet available to you. Data compression. This is when we take the data and we pack more into the packages that are sent on the internet. And that's getting faster and more complete. Broadband networks, that means we can take digital data and share that wirelessly. And so we don't have to wait for a cable connection. I remember my first computer systems we connected in the mid-1970s. There were cables all over the floor because we had to have a wire going between them, and now it's in the air. And now we get to quantum processing, where we can get exponential speed increases over classical computing. But I assure you, that's not on my laptop yet. So there's things coming that we still realize there's going to be more and more speed, more and more memory, more and more access, and the question is, what do we do with it? Now, the problem is that when we get into all of this, we start seeing there's something that's called technology bloat. And this is like when you've drunken a lot of water and you just don't feel like you can move. In the software world, it means there's useless data. I mean, we're growing the data in the internet, doubling it every 2 years. But that doesn't mean it's all good. There are a lot of pictures of cats. There are a lot of pictures of what my daughter had for dinner and stuff in that internet. And then there's also data that I'd like to have. I can't say that I want to see what my daughter had for dinner, okay. But there's lots of data that doesn't add value, let's put it this way. We can't use it in the business world. So then the question is, what can we do with all of this technology? And as we start looking at it, well, we can have distributed processing. So we can have multiple control centers that allow us to operate robustly despite breakdowns or overloads. Typically, what would happen in many factories is a single system where we have central processing. But now things can be done in a distributed way. We also see we can have automated detection, where we have sensors remotely capturing minute changes in the system, and we can now start seeing, okay, let's react in a more real-time environment to what's happening in the system. We can have remote diagnostics. One of the companies here in Finland that's not very far from here is Kone. They make elevators. And for about 15 years, they have had systems monitoring elevator performance through the internet. And they can actually make the remote changes to fine-tune the way those elevators operate as they see changes in the systems that tell them something needs to be done, or even get a cue that says, come and send a service operator. It's more than we can handle by computer. Adaptive learning. As we start looking at this data over time, we can learn from the patterns of change that we see. And we can use this as one way to understand what needs to be done, or is there a problem coming? So also close hereby is a refining company, Neste Fuels, and they make renewable fuel. So they'll make fuel out of fish fat and animal fat and all the bad things that we tend to throw away, and they turn that into fuel now. And so they can actually learn from the patterns of the way the refinery operates. Is there getting time where we need to change catalyst, or we have to change the temperature, or recycle the materials in the converter systems? We can also have integrated control, where the systems can control each other synchronistically, and they can talk with each other and then manage the flow. So many of you are worried about lean production, and that's where we start thinking, how do we manage the flow? And here what we see is the system manages the flow for you. We just have to set up the parameters. It senses what needs to be done, and it takes care of that. And then we can also have predictive analytics. And this is where we reduce future risk or improve the real-time control of the system, because we can predict exactly what's going to happen with some degree of probability. And this is exactly what Deming was talking about when he talked about profound knowledge, that we predict the future with some degree of probability. So system complexity, though, means that the quality emphasis will shift away from managing the system to the design of the system. In other words, we will have to anticipate all of those things that can go wrong to assure that the system can manage itself efficiently and effectively. And so that means there's going to be a shift in what we do, because we have to get to the front end of this. If you're going to put that system in place and let it run, that means that we have to make sure the system understands what it should do in all the different circumstances. So we also see there's an aging of the traditional quality technologies. It's not just me getting older. The stuff we do is getting older. And so we start seeing there's been an analog to digital techno shift. And so many of the quality tools we have were created in what I think of as the analog age. And they do the manual manipulations and hand calculations. If you think about it, people like Karu Ishikawa, who we venerate in the quality community, he never used a personal computer. And so we think about the tools that they made. They were made to be operated with pencil and paper. They're very good in terms of human activities and things we want to do in a manual mode, but they're not necessarily good for digital age. And so we start seeing these methods don't comprehend the abilities to capture, analyze data via computer systems. In just one example, in an ASQ article I wrote about a year ago, it was out fishbone diagrams. And fishbone diagrams were a good way to decompose a problem in a manual system. But today we can use something like mind maps, and we can start taking a look and more aggressively understand what's happening. And even on some of those mind mapping software, we can connect it to the data and let the data operate. And we can take that another step further if we start looking at automating how you do those connectivities within the systems. And those will be techniques that we will transition to as we get into this design age. We also see that most of those methods and tools were created by people who either had no access or never used computers. And I remember one time I was at a speech and Dr. Fagenbaum asked me, how do you turn on this PowerPoint thing? Like you turn on a machine, and just the language, tells you that even though he had a PhD from MIT, computers were not his thing. He grew up in a non-digital age. And even late in life, Dr. Duran commented, I want to pass away with my hands on my word processor, as he was writing his memoirs. And we haven't called laptop computers or desktop computers word processors since about the 1970s, I believe. They were just a single function. Microsoft Word was the computer, and that was a very long time ago. And so we start seeing, should we reimagine those old methods and tools using new technologies? And maybe in some cases we need to reinvent them totally. So this is going to be a challenge for us as we start thinking that we can't get so mentally locked into the things that have happened in the past that have served our community well. We have to recognize we are going through a global technology shift. And as a result of that shift, one of the things that will have to happen is we'll have to upgrade our tools, our methods, and our ways of thinking. So this is what's laying this requirement for quality revitalization, I'm thinking. This is pumping new life in. That's what revitalization means. And so Albert Einstein identified a challenge that we're facing today. And he commented, well, you can't solve the same problems of today with the tools and methods of the past. And so he said, it's time to sharpen our blunt instruments. And I love that phrase. So a fishbone diagram is a relatively blunt instrument. We can use it, but that doesn't necessarily give us the most information we can get out of that circumstance. We don't get intensity of information out of it. I get connectivity, but I only get a single action connective. The head is connected to the bone. I don't get interbone connections, for instance. And so we know that there are many interaction effects that happen in many processes. And as a matter of fact, most of the tools we use are single variable. And what that means is we miss interconnections. One of my rules of thumb as a quality consultant is if we've had a problem, it's a chronic problem. It's never gone away, and we've applied all of our traditional tools. What that means is it's probably an interaction effect. It's two or more factors moving at the same time that we actually have not comprehended is important. Taiichi Ohno observed that even the Toyota production system should require fine-tuning to make it effective and efficient over time. And this is the activity of the workers in what they call the Jisuikan teams, or the continual improvement teams, the quality circles, or the other team activities that they have in Toyota to fine-tune what they do. So nothing stays still. And we have to take a look at how do we make it work. And so today, Toyota is continually, I've talked with some of the leaders in Toyota. They have a program now to call it Revitalize Quality, pump new life into the system. It's not that it's going away. It's not that quality has somehow become obsolete. What it is that we have to think about it in a different way and then get the enthusiasm back. And so how should we sharpen our blunt quality methods or tools of quality for the digital age? If we don't do it as people who care about quality, who's going to do it? And so this is going to be our challenge. How do we redefine quality for that digital age? Well, first, this problem is deeper and more comprehensive than mere fine-tuning or reimagination can perform. We start seeing that this technology shift is similar to a shift from an internal combustion engine to electronic motor. You just don't plug and play and say, okay, copy, cut, and paste, move motor out, put motor in. We have whole system changes. And as a result of having that motor, we ask, how do we charge this? Do we charge it off of braking systems where we can start finding some friction and use that as a way of adding power back into the system as we dissipate it out to run that electric motor? So we have to think about the whole system, how we'll re-engineer everything. And so the maintenance methods and tools used by one generation of technology must be totally changed to support the new generation. And so similarly, Quality 4.0 needs to evolve in a radically distinct way from the methods and tools of Quality 3.0. And so Quality 4.0 will have this total rethinking. How does a quality system operate? What are the methods and tools of quality needed to support it? And what's your role? Will there even be an ISO 9000? Maybe we have to radically reinvent everything we're doing in terms of quality to meet this stage where the operator is no longer the source of variation, it's the designer of the system. So that brings us this question then, the second question. How do we learn to do smarter data inquiry? And this is the challenge. I've grown up, fortunately for myself, I guess, in a digital age. When I was in high school, we had our first computer. It was an IBM 360. So I was 16 years old and I learned how to program BASIC. I'm 72 now, and I forgot how to program BASIC. But everything now is so much more simple because we've got higher order languages and all these other things happening. So how do we get this smarter data? Well, Deming talked in a 1975 article in the American Statistician about the two types of data. He said there's enumerative data and analytic data. And when we look at this, he treated them as mutually exclusive. And he says that enumerative data is a collection of everything. That's when you're looking at the total distribution. There's no time component in that data. And what you get out of that enumerative data is an analysis of risk. It's basically what you see on a process capability diagram. You see everything, and then you see the upper and the lower customer expectations. And then the other type of data is analytic. And analytic data is where we see the time history happening. And in that time history, what we're seeing is like in a control chart. And we start seeing how everything is moving over time. Now, the benefit of the one is we get risk out of enumerative data. We can see what is the overall effect, but it doesn't tell us how to change the system. With the time series data, the analytic data, we can see causation. And with the causation, we learn we can tie the data stream to the process. So this analytic data is what we're going to be using in the new age, if you will. It will all be time series data. And one of the things we have to look at is how do we do time series analysis better? And so that's going to be a challenge because quality professionals have only used time series data in control charts. And we've used them in X bar R charts. And we've used them in X bar S charts. Well, neither of those charts are applicable in the future. We do not have to actually have samples. We can do this on real-time data. But then all of the rules that we've had for run charts or special cause of variation, they're all invalid because all of those are based on a normal distribution in the data, which you get because you sampled the 5 components on an X bar R chart. And what you're actually seeing on the chart is the averages of averages. And the central limit theorem says the averages of averages are normally distributed. So what we've done is we've actually done a data transposition by using an X bar R chart. We've taken real-time data and turned it into average data, and therefore we missed the true individual outliers. And in a quality system that's based on digitization, you want to see all of the data. Now, we capture the data, we can process it fast. So now it's possible to do that. So it's also no longer true we need to do those things that Deming said in a multiprocessor world. Enumerative data and analytic data are no longer mutually exclusive. We can have multiple sensor streams, we can have parallel processing, matrix computation, and that means that we can now deal with 5 or 6 different components all at once in a singular system. And it's easy to do because I don't have to remember BASIC. I don't have to remember the programming. The data systems will do it for you. There are smart little children who can run around and capture everything and take care of these things. I love it when I work with students in the university here. And I don't have to worry about how all those technologies work. They take care of it for me. I can just be an architect and sit back and say, let's move these together. And so we did an article. It's going to be coming out actually in the Future Quality Progress. And it's how do you do process capability analysis for lean operations? So lean operation, when you're processing time, for instance, that's not normally distributed. You want that distribution to have a particular shape. Smaller is better. Short cycle times is better. So it will never be normal. And even when you sample it in small pieces, it's still going to be having that distribution where you've got a long tail. Things that take a long time are failures. So we have to look at how will we change. So maximizing these conditions allows us performance and risk, allows us to manage them both simultaneously. And so analytic data gives insight into causality. Enumerative data will do the same for identifying risk. So in the same way, we have to think, how will we do data analytics for optimizing process flow quality? So another thing we see is the movement towards data visualization. I call this statistical storytelling. So data visualization, this is how computers manage the data collection and processing and reporting. And for humans, we process pictures much more efficiently than we do numbers. And so what we need to be able to do is to present data in a way so it's useful to people. That means we can take a look at it and understand immediately what's going on. So many of you are familiar with Japanese TQM, and one of the things I love about the way they present data is they use the radar chart. And they might have 5 or maybe 7 variables all at once, and you can see how are they changing at one system. In the West, we don't use that. I rarely find that in any Western company. And what we see in a Western company is I see a linear message that tells us this is how this one data item works. And I don't see the other 5 or 6. And what that means is that I am missing data. I don't have the right intensity. I don't have the right information content. And we can get around that by having better data visualization. But what that also means is we have to have graphical interpretation of that data. How do we interpret it? What are the patterns that we see in the data? And when I was in the United States Navy, I had a program called ADCAC, is Automated Detection Computer Assisted Classification. This is how you find submarines. You let your computers look for the patterns of the signal and the noise that's in the water, and then you get rid of the noise and you enhance the signal. And when you have signals of frequencies in the water that relate to the noise a particular submarine puts out, you call that a signature, and then you can do something about it. Well, our operations also have signatures. We can take a look at the patterns among frequency data or the arrival date or the time delays of different events and systems. And we can graphically interpret those and understand what should we do in a different way. Well, it doesn't have to be me doing the interpretation. Back in the 1980s, computers did those for the military. And today, computers can do this for us in a production environment. And what we can do then at the end is something called statistical storytelling. And this is, how do we present this story so a decision maker can understand? Now, if I take the decision making out of the computer, that's the expensive part, right? So if I take that out and I just present the graphics to a human being, and we have people still in the loop, how will they make those decisions? So a critical design question in evolving systems will be, how much decision control is relinquished to a system? And then how much do we reserve for the people who are operating that system? So I've taken a little liberty, and the liberty is that this term exploratory data analysis was created in 1977 by an eminent statistician named John Tukey. And I see that I like the phrase because it really describes exactly what I want to do. I want to explore the data. And so I've kind of redefined it. And I say, EDA is a new way to take a look at information. And if we take a look and we have this sequence of data coming in, so that's the top part of this chart. And I want to understand what are the physical and logical relationships in this historical stream of data. I can use 6 tools in sequence to build that learning. So the first is the individuals chart. So this is giving me the understanding of what is the sequence of patterns we see in the historical stream of data. And do those patterns tell us something? So is there a trend? Is there an oscillation? Is there clustering in the data? Is there excessive variation? All of those are things that can be detected out of that system. Well, yes, computers can do that, but so can the human eyeball. We do that with an eye chart, an individual's chart. Now, one of the problems we have is all of the rules we have for those eye charts are wrong. You know, we can very easily turn them on in the computer system, but they're wrong. Why? Because some data is maximizing data, like productivity. We want more. So that means the best performance is skewed towards the top of the scale. Some is minimizing, like defects or safety incidents. And that means that will be skewed towards the bottom of the scale. And so if the detection rules are based on normality, it won't give us the right set of rules, and we can get confused. So we have to change that. Another thing we can do is take a look at that same data in a different perspective. And here we can look at it in probability space. And in probability space, I mean we can take a look at this as a cumulative distribution or a probability plot. And here what we're seeing is what's the likelihood of occurrence of each of these different magnitudes of the data distribution. And so on a probability plot, if I see a vertical line, it says all the data is at that probability level. And then as it starts going off, it says a new function is happening. Something different is happening than what it was happening here. And we can start seeing, and the number of distinct curves I can observe visually on a probability plot indicates how many different functions are actually changing or affecting the data stream I'm observing. A third one is capability analysis. We know this is process capability. And here we see CP and CPK. Now don't do PP, don't do PPK. They are figments of our imagination because we never have long-term data. You know, I really don't like the fact that this came out. There's no good statistics paper ever saying we should do that. However, CP came about in the 1970s, or excuse me, in the 1950s. Dr. Duran talked about it as process capability. A couple of guys in a factory in Japan came out with CPK. The little K in there actually means bias. And I've got another article coming in Quality Progress. It's going to talk about this and where this came from. And in process capability, what we see is CP is what you bought when you bought a system. If you think about this in the physical world, you bought a capability. The capabilities are typically described in engineering terms. This is the noise-free environment. And as we start taking a look, that's what you bought. That was a specification sheet. CPK is what you actually have operating today in the system. And CPK you can make as an equivocation to this is what is actually happening with standard cost. The standard cost is the average cost of operating a system. And thank you. My lovely wife is giving me a cup of coffee. This is a little early on a Sunday morning, by the way, in Finland. So in Finland, by the way, we're known because we drink the most coffee of any country in the world. Now, I know coffee's not the chosen drink in India, but in Finland it is. So I'm going to say good morning to all of you and just have a little sip of coffee. Now I'm refreshed. Okay. So when we start taking a look at capability studies, what we start seeing, CPK is the equivalent of average costs. But we don't want average costs. Average cost includes the cost of everything that went wrong. And so what we want is we want the cost that operated CP. That's the lower cost stream. So the challenge is move CPK towards CP as we think about what do we need to do in terms of performance. So capability analysis needs to be interpreted differently. Pareto charts, they describe the recurrence rate of process failures. And what we see with that is that the Pareto chart is usually just based on frequency of failure. But it doesn't tell you, is this failure more important than another one? Is this costing more than another one? So the frequency is just how often it's occurring, not necessarily how bad is the impact on the customer. And so we have to take a look at those from different perspectives. So instead of just this as a frequency of occurrence, Maybe we should talk about cost per occurrence and take a look at this cost. Maybe we should take a look at it in terms of how many sources of variation effects using a statistic like what's the R squared of this in terms of how often it's happening. And so that's a more advanced statistics method. The fifth one is ANOVA, analysis of variance. And here we can get this chart that shows us a process, and each of the different process steps is represented as a box plot. And we can see what's the variation within and between the different groups there. And we can see now where are there bottlenecks, where is there exceptional performance, either good or bad. Can we balance the flow so that it comes through evenly? And then finally is a Yamazumi diagram. I love to say this in Japanese rather than in English because it just sounds so cool. So a Yamazumi diagram is just a stacked bar chart, okay? So in Excel, it doesn't sound so romantic, but Yamazumi has a good ring to it. And what we're doing here is within each of those process steps, we're saying how much do we have in terms of waste? So how much is actually evaluating work, required work, or wasted time? And then we can analyze where in the process do we have, at what bottleneck, can we actually apply lean solutions rapidly to get better performance? And I make the comment in my trainings, I say we need to learn how to process dirty data that occurs in messy processes. Our processes need to get cleaned up, but the data is pretty dirty too. And we have to learn how to launder the data. And so when we start taking a look at this, we start seeing we need to have multiple perspectives of the data. And that's what EDA is doing. It's showing us all different ways we can take a look at the data. And we see the historical data so we can get patterns of causation, identifying special cause, common cause variation. The probability plot shows here are the unique ways the process is changing over time. The customer perspective we get out of capability analysis, it tells us how good are we at promise keeping in what we've told the customer will do. The process perspective on the ANOVA says, are there problems in the process flow? And the efficiency perspective out of the Yamazumi diagram shows there's waste and loss in the workflow. So what we need to do is this helps us discover the hidden secrets. And these secrets are hidden between the data observations. If we only look at one factor at a time analysis, we won't be able to really understand all of those things. So we have to have an approach I call collaborative analytics. So collaborative analytics has three distinct dimensions to it. So first, it's people working together in a network system. So just as I'm now coming into Calcutta or Delhi or Hyderabad, I'm coming into maybe Goa. I understand it's a little better place to go, the vacation place. So we're now living in a world that's totally distributed. And we can have people all over the world working on the same problem. I remember years ago, I was writing a book in 1994, and I had the very first instance that a Price Waterhouse consulting group had 24 hours to write a proposal. And they gave it to 3 of their work centers, separated by 8 hours around the world. And they just passed the proposal electronically through and had it done in 24 hours. And I said, hey, that's cool. And now we think, yeah, so what? So we start living in a world differently. Second, networks can operate together. Our computers can talk to each other, and we can collaborate in this digital world as well. And third, we can have a group of networked experts working on data collection processing to create what I call a hive mind. So this is the hive, whether it's ants or bees, working together for a centralized purpose. And now there's a group in the internet called digital doctors. And what happens is if you're living out in some place that doesn't have an expert, you can dial into digital doctors and have 4 or 5 experts help you on your diagnostics on a case. So the components of this approach are already factual states of existence. And soon they're going to merge together. And so we'll have the human aspect, we'll have the computer aspect, we'll have the expert aspect. And that's what we see is it will be a new world in the future. We don't have to go it alone. So how can we do this on the cheap? Okay. Now I have to admit, Ananda made me think of this because he said, in India, we don't want to spend too much money. And I said, I can understand that. I'm from Scotland. And Scottish people they're frugal. And what that means is they don't want to spend much money either. So I said, well, nobody better than a Scotsman to talk to an Indian about this subject. Okay. So tools for capturing in situ data. This is data as it's happening. So we can have radio frequency identification. So this is just a little chip that we put on things like in a warehouse to understand where is something located in a warehouse or a factory. And then we can track it with a radio frequency, a wireless network. We can use timestamps and barcodes, and we've been doing this for a long time. And again, we can say this is where this particular item is as it passes a scanner. We can also have inspection with visual systems. And so this is saying, does this system have everything it needs to do to operate? So we've used this for printed circuit boards. Are all the components on the board before we solder it? We can have motion detection by accelerometer. And so we can record how much motion is happening in a system. We can have temperature checks with thermal probes. And we say, here is the temperature at a particular fixed location in the process. We can have weight with load cells and record weight at a particular location. Or system noise with a vibrometer and saying, there's unwanted vibrations in this system at a particular location. So all of those are saying, what we have to find is, where is the checkpoint for that particular measure we'd like to have in our system? So just as we have checkpoints in a manual system, we can also have places, checkpoints are digital systems. Now remember, in a manual system, a checkpoint is where you're going to use the measure, say, how are we progressing? It's a monitoring process. We can also have a control point. And a control point is a checkpoint where you monitor, but you can also have a feedback loop to change the process. And when we have the feedback loop changing the process, that's when we have the automated control system. So just by analyzing our factories in a different way, looking for checkpoints and control points, and asking ourselves, what is the sensor that we would need to use to make that control happen? And then buying the cheap ones from maybe Alibaba, we start finding out. I have one of my clients is got rubber factories all over the world, and he's trying to figure out a problem with vulcanization. And it used to be you'd have very, very expensive thermal probes, platinum thermal probes. And he bought a dozen digital sensors from Alibaba, about €1 each, and threw them in the mess and had them report. And he got really good information. And I'm looking at this and saying, for less than 20 euros, and I don't know what that is in rupees, but I'm sure you guys can do it in your head. It's not much money, but he got the same thing as you would have gotten from a platinum thermal probe years gone by. So what can we do cheaply? We can also see we can manage this in supply chain flows. So often the bottleneck in production isn't in the production system. It's in getting the parts to that system in the supply chain. So managing flow of supply and assuring quality as agreed to are very important applications for digital sensors. And so we have barcode labeling, system scanning at critical waypoints, linking barcode identifiers to shipment and quality information. And that gives us traceability of components from the source to the destination. And this was the very first application we did at Hewlett-Packard because the barcode scanners and printers were very cheap. As a matter of fact, we made them ourselves. And so what we can do is we can learn basically where we're going, and we're taking a step towards this idea of central control for something that's very important. The motion of all those parts coming to the point where we have the consolidation in production. We can also understand production throughput. And here we can learn how the process flows and locations where the bottlenecks are. And these are important ingredients to assure lean production systems. But we can also do this in a frugal manner. So barcode labels must be placed on the actual entity that's flowing through production. This is this, maybe it's either the part we're making in a factory, or it's going to be placed on the tray in which we're making it. And as we go through this place. So we'll then see the scanners are placed at the checkpoints. And if we have those wirelessly enabled or capable, then we can have a factory-wide system that says, here is the central historian that's telling us how we're actually moving things through the factory. And we can use R script. So R is a universal programming language for statisticians. So we don't have to use Minitab or SAS or something like this. And we can use this R script for ANOVA coupled with Microsoft Power BI. And we can then get a tracking system put in place. And again, it's relatively cheap. You're not talking about having lots and lots of programmers. You're talking about things that here in Finland, we have the students coming out of graduate school or undergraduate school actually writing that code because they learn how to do it and they don't have a chance. So we have them making up those systems. So frugality doesn't mean without sophistication. It doesn't necessarily mean compromise of capability, just that it's done inexpensively. You know, do we have to do this with massive amounts of re-engineering? We also can see monitoring indicators of process, and we tend to have a dashboard. So these dashboard solutions can get very expensive. And one of the things that I know happens in consulting firms is they want to come in and program your dashboard for you. And I found most of those are worthless. And they say, we'll program for you your balanced scorecard. Half the measures in most balanced scorecard are worthless anyhow. They're reporting about what happened in the past. They don't give you predictive information about the future. So we'd like to understand, how can we control production differently? So the quality of a production dashboard is not about balance in the measures. It's not about the completeness of the set of measures. It's, does this measure have a capacity to predict quantity and quality of the productive system? If I take a look in the shop floor in a well-run Toyota system, there's only two indicators they're really using to manage that system. One is the amount of productivity completed, that's the level, and then the rate of change is relative to the talk time. So it's the cycle time differencing. And so as we say, it's not a complex system that we can use to manage a production process. And if we build this using Y as a function of X, as we learn in Six Sigma, you know, and we do this decomposition, we can include both quality and cost as key design elements. And so one way we can do this is an old chart Motorola introduced at the very beginning of its Six Sigma journey, and it's called a 4-up chart. And what we see there is I have 4 panels. So these are Minitab panels. The upper left panel is the individuals chart, and there I'm seeing, I actually have smaller is better. This is talking about actually backlog in production in the real world case. This is a real world case, by the way. And I'm moving from 100 days to I want less than 20 days, and I get it into a state of control. The second chart is actually all of the data because I can't quite show exactly what this company did, but you can see that the very wide black line is the capability that's designed, is the achieved capability, and the red line is the CP that was designed in the process. And we see that the achieved capability is nowhere close to the design capability. And when those two merge and we shift them within the upper-lower control band, then we have a system that's locked into a state of control. And I can just interpret that visually. The Pareto chart here tells me which of the rational subgroups is contributing to the loss. So I can then take a look at those. And then the ANOVA chart says, here's the talk time. And then that red line was, that's the design time. And clearly, smaller is better. My talk time is way off my design time. And as a matter of fact, all those little asterisks up there indicate those are the failure mechanisms in production state. So in that 1 4-up chart, I can actually understand what's actually happening for that factory production system. And I can use this as a way of understanding how well we're doing. And if I take a look at this 4-up chart, merge it with a radar chart, I can actually have a very good way of understanding the multiple dimensions of the factory performance. So what we see is the answers to process issues are hidden within or between our observations of the data. And we have to find a way, how can we tell the story? How can we discover these issues in that process and do something differently? So we have to diagnose the early indicators of problems. And so managing risk in any productive process means an understanding of factors providing early indicators of future process upsets or things that will invoke or create a process failure mechanisms. That's what we have to learn. And when we start finding out what will create that, those are the things we have to look for. Those are the key patterns. So reliability of products and their productive processes will be more important design discoveries as systems become more highly automated. We rely on them to produce desired level of quality and productive outputs. So which early indicating X factor shifts the Y wrongly? And now I'm going to come to another one of my hot buttons, and that is failure mode effects analysis. It's totally obsolete. And what we really should care about is the physics of failure, not the failure mode. What's behind the failure mode? The failure mode merely tells you this sort of system happened, and then we got a failure. The physics of failure, the chemistry of failure, the human anatomy of failure, the biologics of failure, those tell us what is the causal mechanism. And those are the things that digital sensors will start getting right. And so we're going to start seeing process analysis importance is going to shift to an imperative in design of productive systems. We have to understand failure states better. And that means when we're designing our systems, we have to design them, force them to fail, and then learn from failure. As many people have said over the time, we learn so much more from failure than if things are operating. If things operate right, all we did was we had a confirmation that we understood how it works. We didn't learn something new. If it fails, I have a golden opportunity to find out something different that I hadn't expected before. So, in conclusion, I don't know what my timing is, but Ananda hasn't yelled at me yet, so I guess I'm not bad. So I want to summarize just a couple of key points. So what will be the next quality level? So do you have to move to quality 4.0? No. Let's just say you're quality 3.0. That's what we call good quality today. And we have to re-engineer the business. So maybe you want to move some frugal engineering tips and save the deep dive for later. So take a look at what are some things we could do. Maybe we could apply this EDA logic. Maybe we could use some 4-up charts and get some more profound knowledge before we invest heavily in the system. Maybe we can ease into and create a quality 3.5, if you will. And that is where we move halfway, and it's a hybrid approach. The quality professionals are still actively involved and can guide the IT professionals into how do we put this system together. And that way we can ensure the implementation is flawless. One of the big problems I see is if people give all of this and say it's technology, quality doesn't belong, let the IT people do it. We'll obsolete the quality people. Well, that doesn't work because the IT people are not process people. They do not understand the process and they don't understand. And this is what collaborative analytics does. It's going to require relationship building, cooperation in cross-functional partnerships. Yes, our jobs will change, but so will the IT people's jobs, by the way. And as we start thinking about this, then we have to ask the second question. How will you be ready for it? So to make that transition in a company, the quality professionals are needed. But we also have to then say, what will we do when the transition's done? Do we obsolete ourselves so we don't have a job? Or do we do something different? I think one of the more interesting insights I've had into Toyota is that we know in Six Sigma that when we start making processes more efficiently, we always can come up with headcount savings. And so we save people. So what do we do with those people? In Toyota, they don't fire those people. That becomes, they take the best people out of the process. And so that then creates the sense of purpose. People say, I have something to do. So the excellent people become then the water beetles, the supervisors, the people who help everybody. They're the trainers, they're the troubleshooters. And so they go back into the system to still work on that. And they become supervisors in training. So if we take a look at ourselves, we have to figure out what is going to be our path forward. So how well are we doing in terms of our knowledge of systems engineering, design thinking, time series analysis, predictive analytics, SQL data query languages to go in and find out what's actually happening in the data. R is a statistical programming language. I'm getting to the point where I hate Minitab because somebody made a decision about how to use it. I don't want to use it that way. The Minitab assistant, I forbid anybody from touching it because it is programmed to do things in a classical way. I need people to think. And so R makes you think. Microsoft Power BI, it's an easy way to start getting into dashboards and control systems and reporting systems. And then we start seeing, oh, now we get into the expensive stuff, right? Artificial intelligence, machine learning, deep learning, neural networks, big data, optimal estimation. Well, that's the advanced set. And some of us are going to have to design those systems. So we have to learn about those types of things. And if you go to talk, ASQ is having the Quality 4.0 Summit at the end of next month, and you'll start finding out, we're starting to probe those areas. What do we do about them? And so active engagement in the transition to and management of Quality 4.0 is going to require a retooling of quality professionals. We need to take an honest look at ourselves and say, what do I need to do? How will I help to make that journey forward? So I've come to the end of the story. I hope we have some time left. I'm not sure. Ananda?
Yeah, thanks so much, Greg. This was very engrossing, I would say. So I open this session for question answers. Please use the question box that's on the right-hand side of the panel. Moment to click on the panel. If you have any questions, please do ask. We have already have some couple of questions we have received during the session itself. While I welcome other people to ask their question, how do we see the certification process of ASQ evolve with Quality 4.0 expectation? That's the first question I had.
Well, okay, that's an interesting question. I'm not involved in certification. The certification board at ASQ will probably kill me for what I'm going to say, okay? But I do hold I hold all of the engineering certifications at ASQ. And one of the things I see is you can't use a computer to take an ASQ certification exam. The implication is you have to do everything by hand. That's going to have to change. And then that also gives a whole bunch of problems in taking a test, right? Because there's somebody cheating because they have a computer. But we have to get to that point where we can do things in that world where we're going to work. Quality engineering and reliability engineering, in my mind, will merge in the future. Because the definition I use for quality in the future is it's the persistent pursuit of goodness. That's what we think of as quality, coupled tightly with the relentless avoidance of badness. And that's what we usually mean by reliability. But as we're thinking about these, we have to then think about both components as a singular discipline of engineering. And so as we start thinking about it, we'll have more comprehensiveness in terms of certification systems. Software and hardware. Yeah.
Yep. Please go ahead. Please go ahead.
Software and hardware will probably also be merged together. And so that's a radical rethinking of certification process. Now, it takes a couple of years to do those things. So your certifications are still good, don't panic. And you always have to learn how to do it in a manual mode before you automate it anyhow. Okay. So they're not overcome by events yet.
We must know the why before we how to do it. How there is technology always there to help us.
Yeah.
Just on the, you brought up an interesting point in terms of, the mixing of the engineering and the software part. Where does the quality as a profession really come in, providing a mix about the engineering science and the, the technology science? Where do you see quality professionals evolving in this? Do they also start understanding languages and all those things like the R's and the Pythons and things?
Some of us will. And then some of us won't, because here's the thing: is we still have people. As long as you have people in the job, you're always going to have a soft side component of quality. And darn it, the people are also, we call them customers, right? And so as we start thinking about that customer environment, there has to be a human interaction to understand them. I don't think that. So we have different types of tools. I don't know how familiar everybody is, but machine learning is basically an automated learning process. It's a part of artificial intelligence. It's looking for patterns and rules in data. Deep learning is where we have massive amounts of data. It's coupling big data and machine learning together. That's what deep learning is. But that doesn't get to the nuance of the human. I'm reminded of something that Carl Jung said in a 1957 book, where he argued, don't go for averages. He says the average destroys the individual. So the individual, we call them an outlier. Well, that doesn't mean we want to get rid of them as humans. That means that we have to understand them. And so as we start taking a look at the future, we're going to start seeing that we can't just automate everything, particularly the human interface components. And so there will always be some role in that, whether we're talking about ergonomics, making it safe for people and easy for them to move, or we're going to be talking about the thinking processes.
I have a question where somebody is asking in terms of, can you suggest some good books where one can refer on Quality 4.0?
Actually, I can't. The first book has been just published by ASQ, and it's written by Nicole Radziwill. She has come at this from a technology perspective. And so she's talking about what I would call the ecosystem of quality. So you're talking about big data, how does that fit together, neural networks and so forth. And certainly that's an important component. But it doesn't actually include all of the tools, the transitions, and everything else. So that book has not yet been written. I think that what we can see is that before the book is written, there are lots of articles happening. And there are some articles that I've written in Quality Progress. So a year ago, I wrote an article on the ascent to Quality 4.0. This is going through what was Quality 1, Quality 2, Quality 3, and now what's Quality 4.0. How are we getting there? Recently, I just wrote another one. What is the infrastructure Quality 4.0? And let's talk about another important component is that what we're seeing is QA, QC, they've merged in many people's minds already. But QA originally was just preserving minimal quality. QC was controlling you at the level of you'd like to be. But then quality planning is taking you to the next level. And then as you start taking a look at this, and then culture and benchmarking, how does that all fit together? So I said, okay, you're going through, that's quality management is the first component, what we've done. China's already declared they're going for quality development. So quality development is looking at bringing in tools and so forth. And then I say, and when you have leadership through quality, you've got the manual component, quality management, you got the automated component, quality development, now you add the culture. And that's because the people never go away. And the leadership through quality, it's an old phrase Xerox used a long time ago, but I'm an ex-Xerox guy, so I guess I have the right to use it. And that's where we're going, I think. We'll have these two components. So just like we'll have a human component, we'll still have that. We'll also have a technology component. So yeah, some of us will be Python programmers in the future. Or we'll understand what's good about Python and what's good about R, because neither of them, one of them is a statistician's view of the world, the other is a programmer's view of the world. And so when do you use what? So somebody's got to make some of those choices. But it comes back to also understanding what are we trying to control? What's that process? And so that sort of holistic thinking doesn't happen with just a technologist going in and grabbing a piece of data and a monitoring system saying, okay, I can automate that flow.
And if I say that, India is a IT hub, and in that respect, we have been developing a lot of the backend software has been developed in India, whether it is for Microsoft or anybody, the large corporates, Google and things like that, they all have their development centers here. So we have also the industry, the IT industry, and what we call as the business process outsourcing or the knowledge process outsourcing, which is what we call as the ITES. And so there is a question is that how is quality perceived in ITES, and what kind of tools are used for quick result, quick result? And then the question is, do we really need all the tools of black and green belt to use it? So the black and green belt, all the tools are not required. That's definitely for sure, but I'll let you to answer that particular question.
Okay. That was not a small question. That was like we cover the world with one question. Okay. So let me start with the Six Sigma component, because a lot of people look at this as state of the art for quality. Well, I don't think it is. And we have to realize that, first of all, disclosure. I wrote the first training programs ASQ had for Six Sigma. I was the only master black belt in 1997 when we got the rights to it. And I had done program design and stuff as a consultant and in companies and so forth. So I put the program together. We monitored the first 4 programs with the classes. I had one of my employees there, and then we made it work, and then we trained the trainers, and then I got out of the business. I don't want to have a monetary stream coming from ASQ. I think as a past president, I felt like that was a conflict of interest. That's my personal view. It's not implying on anybody else. And so when I take a look at this, in 1997, there were no green belts. Green belts happened in 1997 because Bombardier couldn't train enough black belts because General Electric and Nokia mobile phones had taken all 12 of the black belt instructors that existed in the world at that time to train their companies. And Bombardier wanted to train it, so they could only get part-time access to people. So they created the green belt. And the green belt was to assist black belts in doing things that were time-intensive, data collection, something like this, facilitating an FMEA, facilitating a fishbone diagram, or a process mapping. So that the black belts were actually saved mostly for computation effects. So they're going to run the ANOVAs, they'll run Minitab and so forth. And so the net result was that they created this intermediate position. In 1991, I had a debate with Dr. Kano in Japan, and it was on the distinctions between Japanese TQM and Six Sigma. And one of the things I did in preparing for that debate was I compared the various training programs JUICE has versus the programs that were evolving for green belts and black belts. And my observation was that the supervisory training done for factories, there's 2 levels of it, but that's actually more in-depth than green belt training and Six Sigma. And there's not computers in it. It's all manual. You're helping the people in the work. That the engineer, the quality engineering training there is basically was the equivalent of black belt. There was only a 5% or less than a 5% difference in the 2 curricula. And Takanori Yoneyama, who was the president of JUICE at that time, said, include this in, please, but don't bring the Six Sigma statistic. And basically the Six Sigma statistic is horrible. I haven't used it for over 20 years. It's got all sorts of problems, and it's not worth getting into right now. But so you can use just process capability, and using process capability as the language of improvement allows you to link directly to what's happening in the real world of the customer with the specifications, and the real world of the process with the variation chart. Now, as we start taking a look forward, of all of the tools, hypothesis testing to me is obsolete. We don't need to do this, and I declared this at a Six Sigma conference 2 or 3 years ago. And that is because it's a single univariate factor. And you don't understand, is that factor potentially have a catalyst effect with something else? And so it may not be significant on its own, but in combination with something else, it may be highly significant. And so in the world of digitization, I don't want univariate statistics. I want multivariate statistics. And if you start taking a look at all of the green belt and black belt tools and say, what are I going to bring forward? We will only bring forward multivariate tools into the future. The other ones you use, like in baby steps, is how you teach people how those multivariate tools work, but they're not necessarily the ones you actually use. And so when I go into a complex problem, I'm using basically the tools I showed you, the 6 tools in EDA, and I'm going into experimental design set. So that's for project work, okay? I'm going to take another look on the lean side of our thinking, okay? We don't need those tools. What we need to do is we have to manage the flow, or let the flow manage itself, as the Japanese would say. And so in that process there, I'm basically worried about the time series analysis and the flow. And that's a totally different set of tools. It doesn't require all of the sophistication. So as we're looking at those things, we're going to see the requirements, if you will, advanced analytic requirements change. And so the black belt will change in terms of its capability. green belt will change, and I think it will merge more down towards what we think of as lean. But these are, I'm going to say, in the next decade that this will happen. I'm not exactly sure how fast that change will happen, but I know I worked with ASQ 25 years ago. I'm still willing to work with ASQ and helping. How do we actually make that happen? And that's something I think ASQ will probably end up taking a leadership role in the future. We have to get through this COVID-19 first, but that's creating its own mess.
That's right. So let me just quickly take, there are several questions. So quickly, we'll have a quick, what do I say?
Lightning round.
Yeah. So I have a question like, my question is, your proposition is too statistics oriented. Don't you think the role of human will be further reduced? How do these solutions are developing countries like India oriented? So that's one question.
Okay. Well, anytime we deal with data, we're in statistics. Okay. Yeah. And humans are not statistics. So they're individuals. So I actually separate the humanity side of quality and the statistical side. So the big data, the QSAT, it's all going to be about data. Okay. And so as we start looking at this, that's the data side. The actual design of the process itself is the human side. And so what we'll see is that's the way I designed these two separate.
Yeah. So I'll quickly go to the next question. What is the best university education to comprehensively learn the relevant tools for the new paradigm, including all that you had mentioned in the summary slide for preparing for the quality professional? Coming back to that education part, then what is your recommendation?
Well, I think that, I mean, when I was young, I didn't know what I wanted to be, okay? So I majored in my bachelor's degree in theistic Vedanta. Now, get over the shock, yes, I had a professor from Banaras Hindu University teaching me about Bhakti, Avidya, Maya, etc., okay, in Sanskrit. Now, here I am today doing digital technologies. The choices you make when you're young are not necessarily the ones you'll grow up with. Okay, so things have changed in my life a little bit. But what happened is that we have to stay on top of the times. And I think that's the most important thing. Don't think that your education is just a one-off thing. You need to continue learning through life. And that's, I think, one of the things like the ASQ certification program is good. I didn't do all my certifications at once and say, okay, now I've got it. You know, they came over time. And I use that as a way to challenge myself. Do I know this field? I remember I got the compact computer, and I had people that were in quality had no idea. So I said, everybody in my department will take the ASQ CQE exam. And I remember one of the smart mouth kids there said, oh, Mr. Watson, are you a CQE? And I said, no, but I'll be in the classroom with you. And then I said, crap, if I don't pass the exam, what's going to happen? I lose all my authority. So I had to pass the exam, and I did. And then I remember about another 12 months later, one of the guys in engineering said, well, you're not a CRE. You can't tell me what to do about reliability engineering. And I've been doing reliability in the Navy years before. And I said, well, no, I'm not a CRE. I better get that one. You know, do I really understand everything? And so I took those as challenges to myself. How much do I really know? And so we have one place where we're developing ourselves, and this is your brand, your personal who you are. The certification is the stamp of approval that you have gotten beyond a minimum level of understanding and application in that field. So for me, if I go to school now, if I was going, I would say learn industrial engineering. It's no longer just about industrial, it's industrial and systems engineering. It's taking a look at hardware and software and how it all comes together. I ended up getting a master's degree in that. That was my last master's in 2003. I just finished my doctorate in industrial engineering. I'm now starting a postdoctorate in industrial engineering. And my reason is because I want to study some of these connectivities that are not clear.
Interesting. I have got another question. In fact, I would relate with that. The reason is that when I was pushed by one of my customers saying that, Ananda, you'll appreciate ASQ certification once you give the examination and go through it. So my appreciation for the certification, I may be working for ASQ, but that appreciation came just after I gave my examination. And my son was also giving the examination. So whether will I pass or not, a similar kind of situation that my son has passed his exam. He was asking me, when will we get to know your exam results? So,
I have 3 children.
Right.
And all of them have been through the basic Greenbelt certification.
Oh, lovely.
And one of them is a specialist in Chinese language, another is a nurse, and the third one is an artist. And so I think that everybody needs to learn basic problem solving, and that is one way to say you've learned it.
Excellent insight. I've got another question. Do you see business excellence models evolve in the digital world? Are these models still relevant in a world where CEOs want instant results?
Okay, so business excellence. Okay, so right now I see that there's going to be the quality community is divided into 3 camps about what quality is. You've got an ISO 9000 camp, which I'm going to call minimalist quality. That's a standard. Okay, that doesn't buy competitiveness. It says I have market access. We've got Six Sigma, which is a project-oriented improvement program. Actually, those 4. Okay, so Six Sigma is about project work and making sure we get the projects. However, we also have sort of this lean component, and that's process work. And so process work is about asking 5 whys. Now, one problem with Six Sigma is that you have to have data. And too often you have to wait for data. But if I'm running a factory, I can't wait to fix the quality problem. I have to fix it now. So one type of problem is the instantaneous fix the problem. Those have to be lean solutions. The data solutions about how do I make the system perform better for the future? Those should be the Six Sigma solutions. So this is how we do the improvement projects. Business excellence is actually about an aspiration quality. And I call this a strategic direction of quality. And if I go back, I was an ISO 9000 auditor. I was a Baldrige examiner. I've been a judge on a half a dozen different quality awards. And when I take a look at this, what I see in that process is I see that there is a need to wake the executive up to how you use quality as a differentiator of business. And this is one of the reasons I'm doing a postdoctorate in India, is because I see that one of the foundational problems in the world, and I mean this seriously, is that quality is not a part of macroeconomics. Quality has been relegated into the firm in microeconomics, and it's about the source of supply and demand and how good it is, and can you get value and the pricing model. And that's why executives say it's not my job, because that has to do with product quality. That's in the organization. My job is the world outside, the externalities. But one of the problems in this world is we have not moved quality into that domain. So one of my good friends in India, Ram Ramanathan, is, you know him, you can tell his name properly maybe, but Ram and I have just finished drafting a new quality manifesto. And it's to work in the digital age. How do we call attention to the transformation we need to make in the next 10 years? And as a matter of fact, tomorrow we are meeting. We've just had outputs to the International Academy of Quality. We've got all their feedback back, and tomorrow we're going to meet and start editing the final version. Our plan is to publish this in Quality Progress. And the idea is we've had quality manifestos in the past, but they've all been based on historical things. The original quality manifesto was 1986, before the digital age. So how do we think about this? And we're also now becoming more socially aware. We're becoming aware of the environmental impact. What is the impact on planet Earth, if you will? What is the impact on my brothers and sisters in India or in China or in South America? It's not just about what's happening in my little family or my home sitting here in Finland. And we see this interconnectivity of people. What's the role of quality there? And quite frankly, the economic community makes so many judgments about GDP, for instance. And GDP actually is a waste processor. You know, if you have a healthcare operation and they make a mistake and you have to have it again a second, a third time, each time that they do that mistake correction, that counts positively towards the economic benefit produced by the country. That doesn't make any sense. And when we have a war, we have money coming into the country's getting better, and yet we're destroying things. That doesn't make any sense. And what's missing to me in both of those ingredients is we don't have a higher definition of quality. Where's the goodness in war? Where's the goodness in a failed operation? And so what we have to do is we have to change the definition of quality so it comes up and is equal to quantity. Right now, economics is about quantity, not quality. And so that's why I'm doing my doctoral dissertation. I want to write that paper this year because I think that this is a very important one, not just for our community, but for the world.
I've got a lot of questions, but I'll just quickly summarize one or two. I'll just pick it up so that, I'm sorry, but I cannot take all of them. How is the quality function likely to get apportioned between process engineering, R&D professional, and quality engineers in the future?
I think that what you'll have is two communities in the future with quality embedded in both of them. So I think you'll see quality embedded in R&D as a design component, and it's the professional people who do with the data. Because one of the things you start seeing in R&D is you see the chemists, you see everything else. That's all in R&D, but you don't see the quality professional there. Okay, right. So I think that will become embedded in that R&D as a co-function, if you will. And then in the process side, we've always been there, but what we start seeing is people now calling it process engineers. And so I think of quality people as process engineers also. And so we may lose a part of our old identity. And that part of the old identity was what was kept up with, I'm going to call it that old quality 3.0. We had to have an individual person there. But now we don't necessarily have to have that. We have to have this capability in the system. And we will be the people enabling that system to have that capability. So it's like in education. I was amazed when I did my doctorate. I went back in the history of where quality came from. And back in the 1860s, if you wanted to get a degree from Oxford, you could have it in natural philosophy or moral philosophy. That was it. What happened to all the majors? Well, they happened after that, right? And moral philosophy broke down, and so now you have chemistry, and so those are natural philosophies, but those are distinct, okay? And in the moral philosophy, you've got ethics. Well, psychology, where is that? Well, that goes into the science side because we're studying man, but we study that in a soft way. And then on the moral side, we have pragmatism. And what is pragmatism? Well, that's the basis for a lot of the philosophical thinking in terms of quality. And so we start seeing all of these divisions happening because the way we look at universities. And what I start seeing is that many schools are now starting to bring back a systems education program where it's like, how do we knit these together? So my oldest grandson is starting university right now. He's just starting his freshman year. And he says, what do I study, Granddad? And so we sat and we talked about many things. And so he says, I want to do something in the field of finance. I said, well, then you have to major in both finance and economics. He says, why? I said, okay, accounting just keeps track of money. Okay. Finance tells where you're going to invest it. And economics says, did you do it for the good? I said, so it's not one question. It's multiple questions, and they're integrated. And so we have to start seeing the systems perspectives behind things. And I think quality people are uniquely equipped to do that, because when we do problem solving, we have to sort through the systems.
It brings me to I think there are several similar questions which I'm picking up in terms of, I think the sense that I'm also getting from the question that I see here is that a lot of quality professional wants to know where all in going forward, and whether it is now it is quality 4.0 we are looking at would be the industry 4.0 and all those things. How can I what all investment in knowledge should I do right now so that I'm a little future ready? So and it's a similar question that is coming in terms of, they're a little worried. I wouldn't say worried, but they would like to know that where all should I invest myself currently to upgrade my knowledge? And
Well,
so that's the other direction.
first thing, ASQ actually has an answer for you, and that is that in the quality management division this year, I have volunteered to do 1-hour webinars each month, and so we've done now 8 of them. So August was done, and next month I'm doing the 9th one, and so there's 3 more, and the last one I end up with is on this question. So it's like, it's not a question, it's a lecture. And I'm doing a series of 4 webinars for the Russian quality organization, just on quality 4.0. And the last lecture in that is the same question. And it comes down to, do you know who you are? Do you know what you know? And do you know what you need to know? And so I can't tell you what to study because I don't know who you are. I know Aninda. He's sitting there. We've talked before. I have some feeling for him. But I don't think he's a mathematician. Am I right?
Right.
Okay. So I can't tell you what to take, right? I can't tell you, do you need to get into the technology side? I can tell one other thing I know about Aninda is that he's a people person. He likes to talk with people. He likes to deal with people. And so my guess is I'm going to position him on the human side of quality. Okay. And so if he's going to develop there, what does he need to develop? Well, I don't know where he is. You know, so what I think is we all have to take a reflective time. And in that reflective time, we have to examine where do we want to go with our career. If the career separates and we see one strong technologist side and one strong people side, where do you want to be? And in large companies, there's room for both. In small companies, it's even more of a challenge because now I'm not going to have so many quality people that maybe I have 2. And so this is going to be one of the things the quality profession has to deal with is how do we then scale up and down quality professionalism? And how do we make it so that it's easy? I've spent the last 2 years going to Africa. And I'm not doing this anymore because of my health and the COVID thing. But I was training quality professionals in 5 different African nations. And one of the things I found was that their idea of quality was just follow the checklist. And they had no idea that doing work and improving work were both parts of quality. I mean, we just improve the checklist. Yeah, well, when you know it's dumb and you know it's dumb, why don't you fix that? Well, that's what the boss said I had to do. I want to be a good employee, so I follow the dumb things he said I should do. Well, at that level, we need to educate people, right? And so we don't want to be doing stupid things in the process. We don't want to be doing dumb things. We want to keep getting them better. And that sort of attitude, that culture, we need to build into people, whatever they're doing. And then the tools they use, what we're building in Africa, it's very simple tools. I'm actually taking university students who have not even gotten their master's degree finished. I'm taking them to Africa to instruct. And they're instructing the leaders in their communities, 30 to 40-year-old men and women, about how do you do these things. And this is, it's amazing to me see the dynamic. So these young kids are going down, they're getting practical experience they never would have gotten in university. And then the older people are learning about all these advanced things. And then every now and then the young kids show them a tool. They say, whoa, look at that. And then they start finding out some of them want to go into that other area. And so my advice, I think, to everyone is keep trying. Try different things. I mean, the wealth of educational opportunities today is tremendous. I'm going to be starting putting lectures on Udemy. And I like this tool because I have a series on Udemy I'm doing. It's going to be quality for executives. And when I charge that in a company, I'm charging big bucks. When I put it on Udemy, you can go and for 200 euros see the same thing I charge thousands for. And it's not a short course. It's actually 20 hours of video. There's about 24 workshops, I think, involved in that. There's 10 podcasts to kick them off. There's 120 pages of text to read and so forth. And so what you can get out of that richness there, not just my course, but any of these things, it's amazing to me. I started looking at these things, and now I'm using those for development in my coaching of young people. in terms of how you can get ahead and get faster. And I've actually saw one person on LinkedIn who had 15 different certificates they were doing during this COVID time. And I said, good for you. You know, you're not wasting your time. You're using this to improve your knowledge. And so we may improve the knowledge, but we haven't gotten the experience yet. So we have to blend both of those together. My lightning round is terrible, and I keep talking.
And absolutely brilliant. In fact, we are already running out of time. Normally I close by 12:15. We're already at 12:30 India time itself. I think the last question, should organization have quality as a separate function going forward when Quality 4.4 talks about a lot of collaboration and individual ownership?
My answer to that is probably not. And yet, what I go back to when I was at Xerox. I left Xerox in 1994, and we were consolidating at that time 3 things. So we actually created a chief administrative officer. So when I left, Hector Matroni from Mexico, he was a quality manager, took over that job. And that was quality, yes, that was one subset. It was also personnel, HR. It was also information technology. And I think that trio actually works well in the future because you've got the human development side, you've got the data component, and you've also got then this other component about the quality technologies and improvement processes.
I'm still getting a lot of questions, but let's, I think...
I'll tell you what, I'll make you a deal. Collect questions and send them to me in an email, and I'll write some short answers back.
Brilliant. That's exactly what I'll do. In fact, this whole video would be available on ASQ South Asia YouTube. And what I'll also put in the links of some of the quality progress articles that you had written. So I could put those links as well. Plus, you know, the questions that still remain unanswered here itself, we can see looking at. So please write into asqindia@asq.org. We'll be more than happy to. I'll be more than happy to share it with Greg, and we can have those questions and answers put up in the link at the on the YouTube channel itself. So with that, Greg, thank you so much. Really appreciate you taking your time out. Sorry I woke you up early in the morning.
It's okay. I don't know if my wife will forgive you, but I will.
Very kind of you. Please send me my regards. One of our common colleagues who would be coming in from US. I'm still trying to figure out because the 11 a.m. the timing that we have on last Sunday, and how will that match up? Because that's going to be at 1 o'clock middle of the night. I'm still trying to figure that out.
Well, when I do the webinars for the U.S., I'm starting at 1 o'clock in the morning till 2 o'clock. So I have no sympathy for them.
then I should not feel too guilty about waking you up early in the morning.
Yeah.
So great. Thank you so much. Really appreciate your time. Thank you so much, participants, for your time and being patient here with us. Look forward for our next session. It's going to be from the Tatas and how they are dealing with the COVID time. So please to log in. The details would be shared. If you're not getting those information, please write into asqindia@asq.org. Folks will write into you, and we'll send you the details of our next webinar. With that, Greg, thank you so much. Thank you all for your participation. I look forward for the next session itself. Thank you.
Thank you. Bye-bye.